So let's begin with a definition of evaporation. Evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into the gas phase. Let's review what temperature is. Temperature is the average kinetic energy of the molecules within an object or substance. So when evaporation occurs, the high energy molecules, they can escape the surface. The medium energy molecules are pulled back into the water, and the lower energy molecules remain within the water, within the liquid. You can think of this like your test grades. Imagine you have all your test grades and your teacher tells you he's going to drop one of your test grades. But the catch is he's going to drop your highest test grade. Now you wouldn't like that because, as you can quickly calculate in your mind, your average would drop. So it's the same thing when it comes to evaporation. If your high energy molecules are escaping, then the average would also drop. Since the average kinetic energy of the molecules is known as temperature, then this is an important thing to note. Evaporation is a cooling process. It always drops the average kinetic energy. In other words, it always lowers the temperature. Some factors that affect evaporation are: 1. The temperature, and this may refer to the temperature of the surroundings, the ambient temperature, or the temperature within the liquid itself. As the temperature increases, the rate of evaporation also increases. Surface area. As the surface area increases, the rate of evaporation also increases. Wind velocity. As the velocity of wind increases, the rate of evaporation also increases. And density. As the density increases, the rate of evaporation decreases. So 3 out of these 4 factors here are in a direct relationship, and 1 is in an inverse relationship. You have encountered these in your everyday lives already. You know that when something spills on a hot day, it evaporates much quicker than it would if it were spilled on a cold day. Same thing for the surface area. If you want something that has spilled to evaporate quicker, what do? Spread it out. The greater the surface area, the quicker it will evaporate. On a windy day, things are going to evaporate faster. If, let's say, you are mopping and you want it to evaporate quickly, you want it to dry up quickly, would you keep the room that you have just mopped closed up, or would you open the doors and the windows for it to dry up quicker? You know what the case is. And density. Thicker liquids take a longer time to evaporate. And when I say thicker, that's just a loose term for density, right? Let's look at boiling. Boiling is the action of bringing a liquid to the temperature at which it bubbles and turns to vapor. So in conjunction with this, we need to know what is vapor pressure. Vapor pressure is the pressure caused by the evaporation of liquids. So what happens in boiling? Normally, you have a heat source here, a flame, right? A fire at the bottom of the container. And what happens is that fire there causes greater vaporization to start to occur at the bottom surface here, at this bottom surface of the liquid. And so little bubbles are formed. And then eventually, these bubbles, they want to expand and expand. And they increase in pressure. That's the vapor pressure, right? And eventually, they will increase in so much pressure that they become greater than the atmospheric pressure pushing down on the liquid. And so when these bubbles form and their pressure overcomes atmospheric pressure, then they go up to the top and the cooler water comes down to the bottom and more bubbles form, and the process repeats itself in a convection current until eventually all of the liquid is forming bubbles that rise up to the top, and they turn into vapor at the top and escape the top surface of the liquid. So what are some factors that affect boiling? First, atmospheric pressure. The greater the atmospheric pressure, then the higher the temperature at which the liquid will boil, and vice versa. The lower the atmospheric pressure, the lower the temperature at which it will boil. Why is this important? Well, some people like to climb high mountains, and the higher up you go, the less atmospheric pressure there is. So when you're climbing someplace really high, like Mount Everest, for example, you can't climb that in one day. So you have to take food with you to cook for that many days journey. So if you were to cook in a normal pot, since there is less atmospheric pressure, the temperature at which the water would boil would be lower. So your water wouldn't boil at 100 degrees Celsius. It would boil at a temperature less than that. Since it is boiling at a temperature less than 100 degrees Celsius, it wouldn't cook the food properly. The different bacteria that are present in the food wouldn't die. such as E. coli. So instead of a regular pot, what they do is they take a pressure cooker. The pressure cooker keeps the gas sealed inside, right? When the steam is produced, it's trapped inside, and so the pressure builds up and builds up. And so as the pressure gets higher, then you can get a higher boiling point, and so that way the food will cook properly. Another factor that affects boiling is impurities. The more impurities there are in a liquid, then the higher the temperature at which the liquid will boil. Let's compare boiling and evaporation. Boiling occurs at a fixed temperature. So for example, water, pure water at standard atmospheric pressure will boil at 100 degrees Celsius. Meanwhile, evaporation occurs at any temperature. So evaporation can occur if the temperature is 10 degrees Celsius, 50 degrees Celsius, 90 degrees Celsius, any of those. Boiling is a quick process, meanwhile evaporation is a slow process. Boiling takes place anywhere throughout the liquid, meanwhile evaporation takes place only at the surfaces of the liquid. In boiling, bubbles are formed in the liquid, meanwhile in evaporation, no bubbles are formed in the liquid. For boiling, the temperature remains constant, and for evaporation, the temperature may change. In particular, the temperature lowers. Important thing to note again, remember, evaporation is a cooling process. With boiling, thermal energy is supplied by an energy source, such as a flame, and in evaporation, thermal energy is supplied by the surroundings. Let's look at some everyday phenomena. 1. Perspiration. This ties in with biology. Why is it that we sweat? Well, we sweat to cool down our bodies because evaporation is a cooling process. How does it work? You put water on the outside of your bodies through your pores, and then that water on the outside of your bodies will eventually evaporate. And while it evaporates, it cools down the surface of your body and the overall temperature of your body. So that is why you sweat, to cool yourself down. Another everyday use of understanding of evaporation is in the treatment of fevers. An old-fashioned treatment is when somebody has a fever, what you can do is you can take rubbing alcohol and put it on them, and then you put a fan towards the person. There are two important aspects of that old remedy that have to do with science. First, the rubbing alcohol. It is less dense than water, so that means it will evaporate quicker. It has a greater rate of evaporation, and the faster it evaporates, the faster it will cool down the person's body. The second part of that treatment is the fan. If you put a fan on somebody, you're increasing the wind velocity. So if you increase the wind velocity, you're adding even more to the rate of evaporation of the rubbing alcohol. So that way you cool down the person's body really fast with that treatment, and so you lower their fever.